All right, good morning. Thanks for coming this morning. So my name's Jeremy Seek. I'm an assistant professor here at the University of Colorado. Tell you a little bit about myself. I've been a long-time C++ programmer, going back to the, probably high school or so. I've been very much involved with sort of open source code development in C++. So there's this really neat community of programmers called Boost that produce a collection of libraries. So I've contributed many libraries to the Boost collection, including the Boost Graph library, and wrote a book about that as part of the C++ in-depth series that Bjarne Strustrup edited. I've also been a member of the C++ standards committee from about 2003 to 2008 or so, plus or minus a year or two there at both ends. And so I was part of the standards committee trying to help them improve the language and for the next version of the standard. One of the things I worked on was something called the concepts extension, and that's all about improving the way templates work and the support for a style of programming called generic programming. Unfortunately, that didn't make it into the standard, which broke my heart. But who knows? Maybe we'll get it into the next one. We'll see. Yeah, so I love programming in C++. Well, it is sort of, I have to admit, it's sort of a love-hate relationship. When you've got a nasty memory error that's hard to debug, at those moments I'm sort of hating C++. Or when I'm looking at a giant page of error messages, then I'm not so happy. But there's things that you can do in C++ that you really can't do in any other language. It's got this unique combination of sort of close to the metal, sort of high performance capability, but then you also can create abstractions. You can create classes, you can create templates, and so you can do a lot of interesting things from a software engineering perspective while still getting good performance. Okay, so that's what I think is really cool about C++ and why even today I do a fair bit of C++ programming. So a little bit about the class today and this setup. These classes will be recorded, so I'm recording them for a website called Udemy, and they'll be I'm not sure exactly how much. I'll set the price, but they'll be offered for like $30 or $40 on Udemy, the videos. But for the audience here live, it's totally free. I'd encourage your participation, your questions, and whatnot. We'll go through, at least through March. I might go into April, some depending on sort of how much material we cover. We'll kind of play it by ear. So sort of as long as I'm having fun and you guys are interested, then we may keep going a bit longer. So yeah, so I should mention that we're going to follow sort of vaguely the content of a textbook called Accelerated C++ by Koenig and Mu. It's a great C++ textbook. It's meant to sort of get you up and using C++ fairly quickly, using some of the standard libraries and things like that, and actually try to do some problem solving. So we'll be following the content of that. This first lecture we'll be looking at like chapter 0, 1, maybe into 2 today. All right. We are starting sort of from scratch here, so I'm not assuming any knowledge of C++ whatsoever. So if you're an expert C++ programmer, this probably will be a little bit boring. But if you're totally fresh, then this is the right place. So maybe before I dive in, are there any questions about the course overall? No? All right, great. Well, then let's go ahead and get started. So what I've got up here is just about the simplest, not quite, but almost the simplest C++ program you could write. So what we've got here is a function called main. Every C++ program needs to have a function called main. And what happens is when you sort of run your program at the command line, or you double click on the executable in Windows, or what have you, the operating system is going to sort of trigger execution to start right here at the main function, and it's going to sort of progress from there. Okay. Maybe something to kind of give you a little bit of a view of what happens when you're trying to run a C++ program. So you start out with your source code, right? So here's, my program, that says int main return 40 plus 2, right? So that's this source code here. Then you run that. So I'm going to first give you sort of a very sort of rough, coarse-grained outline of what happens, and then as we go along, I'll sort of reveal more detail of what's happening. But you then sort of run the compiler, right? So this is, could be G++, the GNU C compiler, or the Xcode, from Apple, or, or the Intel or the Microsoft compiler, what have you. All those are compilers for the C++ language. There are minor differences in the compilers. You're not completely guaranteed that if you write a program on one, and have it run on one compiler, that it's going to work on another compiler. Now, the whole point of having a standard, that committee that I worked on, is to try to minimize those situations. But it's a human process, and humans make errors. So you might accidentally, write some code that's maybe non-standard, and then it might happen to work on one compiler but not another. So there can be issues like that arise. But I'm going to be teaching you sort of what I would call standard C++. I'm not going to teach you any sort of funny features that are in one compiler but not in another. Okay. So after running the compiler, you get an executable, right, which is sort of literally, a string of zeros and ones that the computer architecture understands how to execute. And then you actually run the program, right? And that's where the operating system jumps into the main function and starts running it. It may need input. So depending on what program you write, it may stop and ask for input from the user, or it might be a graphical user interface program, and so it's waiting for you to make a click with your mouse or something like that. So the input comes in and you run, and then you also get various kinds of output. Okay, and we'll be learning how to do things like print textual output to the screen and so on and so forth. We're not going to get into sort of graphical user interface kinds of things in this course because it's more focused on the basics of C++. Okay. So any questions about this sort of the typical process with compiling a C++ program? Okay. All right, so getting back to this simple program. So any C++ program is going to be structured, has sort of a similar kind of grammatical structure to it. Okay, so let's talk a little bit about this syntax or this grammar, right? So you want to be kind of, in your mind, you want to be thinking back to junior high or elementary school or whenever you did your sentence diagramming kinds of things. And let's think a little bit about, what the diagram would be for this little program, main. Okay, so every C++ program is a sequence of declarations. Okay, that's at the topmost level. You've got a sequence of declarations. Here, that sequence has to have at least one declaration in it. In this case, this main function. Okay, so functions are an example of a declaration. Okay? But when we learn how to use classes and other kinds of things, those will be other kinds of declarations. Okay? Now, this particular one, this is a function. The int there at the very beginning, that's describing what kind of thing is going to be returned from the function when it's done. Okay, in this case, it's saying an integer. Now, these integers aren't exactly the integers that you heard about in junior high or whenever. This isn't, mathematically the exact integers. Instead, this is a sort of a bit representation of integers that has at least 16 bits there. Okay, the C++ standard says that you've got at least 16. You might have more. And what does that really mean to you? It means that as long as your integer is less than 2 to the 16th, which is pretty big, then you're guaranteed that you're not going to get what's called wraparound. Okay, so that's kind of a funny thing about integer addition. So if you were to take a number like 2 to the 15th or maybe 16th and add it to 2 to the 16th, then you might not get, this would be what, 2 to the 17th is what you'd think you'd get. But depending on how many bits are there, it might wrap around and you go back to 0 and start counting up again. Okay. So this is actually something you'd want to think about carefully. Let's say you've got a counter, and let's say you're writing a server, and you need to have sort of like unique IDs that you're sort of doling out. And maybe you said, oh, I'll just keep a counter, and I'll just use this counter to dole out unique IDs. Well, computers are fast, and so you might be doing this like hundreds of times a second, or even thousands or millions of times a second. So you could very quickly blow out 2 to the 16th. Okay. Fortunately, though, there's other options than just int. There's different types you can choose to tell it to use at least 32 bits or 64 bits, and things like that. So, and once you're up to 64 bits, then that will last for quite a while before that does the wraparound. Okay. All right, so that's what this integer says. It says we're expecting to return an integer. Then here we have the name of the function, main. Now, what comes after the name of the function is a parameter list. Okay, so the person calling this function could provide parameters. In this case, we're sort of saying we're not expecting any parameters at the moment. It turns out later on we'll show you a slightly different way of writing your main function that does take some parameters in. So this is another way of getting input into your function or into your program in general. Okay? So we'll see examples soon of where we have some parameters inside the curly braces there. And then following the main function here, this entire thing is a statement. Okay, and this statement, as you can think of it as sort of a command to tell the machine what to do. Now the curly braces are a way of grouping a bunch of statements together, okay, into one statement. So what I've got here is one statement, but then inside the curly braces, inside the curly braces, you can have a sequence of statements. Now, in this case, there's only one, again, because we're showing you the simplest possible program. Okay? One kind of statement is called the return statement. And what that return statement does is says, I'm done executing this function. I want to return to the caller. Okay? And by the way, here's this expression that I'd like to evaluate and then return the value of that to the caller. Okay? So I want to stop and pause for a second and sort of emphasize the word expression that I use. The expression, think of it as a chunk of source code, like 40 plus 2 here's an expression. Okay? And then when you run an expression, out pops a value. Okay? And you typically, the way it typically happens is you sort of, the execution sort of evaluates the subparts first. So we might have had, a slightly more complicated expression, like this. Okay? So we would have to evaluate this sub-expression to 2, and then it would do the plus for the outer thing. Okay? And that would be, and then you'd finally get the result of 42. So let's go ahead and see that. So first I'm going to compile this. So I'm going to do, so I'm telling it to build. You can see sort of a spew of messages going on down here, and it's saying building workspace, and then finish that. Okay, so now, oh, by the way, this is Eclipse that I'm using as the integrated development environment. So that means, what is an integrated development environment? It's mainly a text editor. So that's, what I've been doing here is editing this text. But it does some nice things like syntax coloring and other things like that. And then it also gives you sort of, when you go and execute a program, it sort of gives you support for sort of stepping through the execution and debugging the program. And so over here, you see there's this thing called variables, and if there were variables in the program, you'd see their values. And we'll see an example of that in a little bit. So here I can just say run. Oh, it's building it again because I made some changes. Now let's go ahead and run it. And then all of a sudden you saw this sort of flash up here, and it said terminated. That's good, my program terminated. They don't always terminate. Sometimes they go into infinite loops. And then it says exit value 42. So it might be a little bit hard to see, but indeed it sort of returned the right the right number. Now these exit values are typically ways of telling the operating system whether your program completed in sort of a normal fashion, the way it was expected to, or whether it finished in sort of like some kind of error happened, okay? And an error, a return value of 0 means everything went fine, okay? Whereas anything other than 0 means something went wrong. So here we're sort of lying a little bit to the operating system. We're telling it that something went wrong, even though, you know, my intent was that it would return 42. So, all right. Any questions at this point? Yeah.
It's a quick question on the IDE. Is there a reason you well, first of all, do you prefer Eclipse than like code blocks or dev?
I don't have a very strong preference IDE-wise. In fact, I'm kind of an old curmudgeon, and so I tend to use Emacs. So some of my friends make fun of me for that. But I picked this one a few weeks back for this class because it's open source. Anyone can download it. It's available on Linux, on Macs, on Windows, and so on and so forth. There's probably other open source ones I could have picked as well. This one's fairly popular, so I just kind of chose it. My sort of advice to you guys would be, you know, maybe shop around a little bit, figure out which IDE you like the best. But then once you choose one, really learn a ton about it, because that's going to affect your productivity, how fast you can write code. You know, you want to be sort of really fast with the editor and with using the debugger and all that stuff.
Which tool chain are you using in this Eclipse?
Right. So this Eclipse is then using the GNU compiler that was sort of I installed the developer tools on Mac OS.
Okay.
And that's what I'm using. I did notice, so I've got another new computer where I've got Mac OS Lion, and things changed a little bit on Lion. You have to go find an extra dialog that says, like, install the command line tools, or else none of this works. Also, there's another little change, is that Mac switched from all GNU tool chain to, with Lion, now they're using the LLVM tool chain. Which was sort of annoying to me because I had to then, figure out what thing to, click on to get it going. But the LLVM toolchain is really a really great one. In fact, one of my best friends, Doug Greger, is the head of the C front, or not the C front. I'm sorry, the Clang sort of, which is the C++ front end to the LLVM version of the compiler, and he works at Apple. Where a lot of the LLVM development happens. Great. Any other questions at that point? Okay, so here we have a function, main, but let's sort of dive in a little bit and sort of talk about functions in a bit more detail. So here I've switched into the code view within Eclipse instead of the debug view. And now I'm going to switch over to a different project, which is all about functions. Okay. So now you'll notice that here we have a C++ program, a sequence of declarations, but now there's two declarations, both of which are functions. We've got the main function down here, and then we've got another function up here called area of a circle. Okay. And then down here, what we have is a function call. Okay. So what's going to happen as our main function is executing, as it's going along, it'll hit this return statement. It'll then try to evaluate the expression, which in this case is a function call. That means it's going to jump, sort of the execution is going to jump up here to this function, and it's going to pass 1.0 into this parameter. Okay? So think of radius, this radius parameter, as a little bucket with a name on it. Okay? And at the point where the function call happens, 1.0 is being plopped into that bucket. Okay? And then later on, like down here, where we use that name radius, when it evaluates that name, it's going to get out the 1.0 value. Okay? So that's sort of the, okay, right. So then the body of this function gets executed, and then we hit the return statement, and so that return value, 3 is going to be 3.14159 times 1 times 1, which is just 3.14159. That'll be returned, and that will actually be what gets, which then sort of pops up here, and then gets returned from the main function. Okay. So let's go ahead and run this and see what happens. I'm going to hit the debug button. So that means we're going to sort of step through this one part at a time. Okay, so we're popping back over into the debugger. You can see there's a little arrow here pointing to where we are. So as promised, the OS has sort of called our main function, and now we're at the first statement within main. We're ready to execute. There's a couple buttons over here. They're kind of hard to see. One says step into, and the other says step over. If I say step into, what that means is if there's a function call, we're going to go and we're going to jump to inside the function call. The step over button is going to say skip, completely execute that function and come back and then keep going. Okay? So I'm going to say step into here. So now we're inside of this area of a circle function. Notice here that we've got a radius variable or parameter that's in scope here that we can use. And then we're going to go ahead and execute that statement, and then return. So we're done with area of a circle. Now we're popping back out to main. That happened to that call to area of a circle was the last thing in main. So now we're done with main as well. And I can hit the resume button to say, well, just finish out execution of this program. Now something that's a little bit odd here, now I think this is sort of a silliness of Eclipse, is it's saying that the exit value is 0. That's not quite right. So let's just run this over again, but not using the debugger. So let's just run the whole thing all in one fell swoop. So now it's saying that exit value is 3. So that's the right exit value. So why is the exit value 3 and not 3.14159? Does anyone know why that is?
Because the return type for main is an int.
Right. And then, therefore...
It truncates the value to what would be expressed by an integer.
Right. So, and it's a little more... Truncate's a pretty good name for it. I think that's the... it's sort of rounding to the nearest integer. And it's happening sort of right there where the blinker is. It's coming back from area of a circle. Area of a circle returned a float. Now, float, of course, is you can kind of think of it as an approximation of a real number. Okay, it's not really a real number. There's many real numbers that it can't represent, but it can represent quite a few real numbers. So it's an approximation. Okay, and you'd actually be surprised at certain numbers that it can't represent. You'd think that, oh, what's the big deal? I think, what is it, like 1.3 or something like that? There's certain sort of simple decimal numbers that you can't represent exactly. So, yeah, go figure. If you want to look, there's some really great slides on the internet about sort of all the nitty-gritty internals of what's called IEEE floating point arithmetic, and that's sort of the people that sort of specify how these floating point numbers work. But anyways, right where that blinking dot is, that's the point where it's being implicitly converted from a float to the return type of main, which is an int, and that's the point where it does where it's rounding to 3, right? Okay, so that sort of explains that. All right, I'd like to say a couple words about this function area of a circle. I'd assert that this is a good function. There are bad functions. Functions are one of the key ways that we create abstractions in our program and the way we organize our programs. And you might think that sort of the more abstraction, the more functions, the better. That would be sort of a naive way to look at it. That's not always true. There's functions out there that I would say are bad because they don't help the human understand the code, either the one writing the code or reading the code. Okay, so I'm going to, just for fun here, I'm going to create another function that's a bad function. And by the way, this good versus bad, it's not like black and white by any means. This is totally like a judgment call, okay?
I think it does just truncate it. It does it with like 3.8 instances.
All right, so I just created this function called pi2. That's not what I meant to do. Maybe I just want to call it pi or times pi. Right, so this function takes in parameter x, multiplies it times pi. Now why would this be a bad function?
You have no idea what x actually represents. It's just a vague variable.
Yeah, that's true. It is sort of any old variable, but then again, so was this guy, right? Or is there a difference between x and these are both parameters.
But you know what you're trying to do. You know what radius represents. You know what you want to do with it.
Yeah, right. You're totally. That's right on the mark. There's this notion of what you're trying to do, and that you're representing something, right? That we're representing a radius, and there's notions of a circle, and that you're trying to compute the area of a circle. These are sort of high-level notions, right? These are ideas that maybe you're trying to draw something on a screen, or depending on the application. And these are things like you can kind of, and furthermore, what's beautiful about this is, let's say you've created this function, and then maybe a couple of years later you forget how to compute the area of a circle. That's sort of okay, because you can call the area of a circle function, be like, yeah, that's what I need, and I've forgotten the internals, right? Now let's look at this function up here, times pi. That name is actually no different than the inside of the function, right? It's just saying, this is what I'm implementing. I'm multiplying by pi. There's no semantic, interesting thing happening there. It's just sort of an arbitrary grouping together of expressions. And the chances of being able to reuse this thing in other meaningful ways is pretty low. And the readability of, let's say, instead of saying this, I said, times pi radius. Is that more readable than what was there before? Or actually, I'd say it's less readable, because now you're looking at it and you're like, well, the function name says times pi, but I know programmers aren't very good at naming their functions, and so I'm not sure if it really does that or not, or what kind of, maybe there's some kind of funny conversions happening, and is it floating point or double precision or who knows what. So now I don't really know what's going on. So in this case, I would say that a much better thing would be this implementation. Okay. So obviously this sort of feeling about what's good or bad is a pretty vague one, but it's just something to start to think about a little bit, and and as you're programming along, try to aim for abstractions that have meaning. All right. Okay, that does it for sort of this basic introduction to functions. Maybe a pause for a second. Are there any other questions at this point about the basic mechanism of, we do the call, we do the return, we've got parameters. So there's a fair number of ideas bouncing around there. All right. Well, now we are ready for Hello World. There's actually, Hello World in C++ has a fair bit going on, so it's not exactly the best thing to jump into right off the bat, which is why I delayed it for a few minutes. All right, so here is your classic Hello World in C++. Okay? Let's talk about this so kind of at a high level, what is this program doing? It's just printing out a string to the terminal that says hello world. Okay, so that's pretty basic. So we're learning how to do character-based output. Okay. What I mean by character is that each one of these guys inside of this string is a character. Okay. And then this thing in quotes is what we call a string literal. Okay, it's just a sequence of characters. We're going to have different kinds of strings running around at different points in time in this course. Unfortunately, C++ has a very complicated story when it comes to strings. But for now, we'll just think of this as a string literal. Okay. Now, backing up a second, so now what's this thing on the first line here? This is essentially, you can think of it as an import. You're trying to import functionality from some other library. Okay? And this, in particular, this library is the IO stream for input-output stream library that's built into any C++ compiler. Okay? So this is the part of the standard library. Okay, so this is part of what the C++ Standards Committee works on, specifying what this library is supposed to look like from a user perspective. Now, the fact that it's this pound include thing is kind of interesting. Okay, so it turns out that in some sense the C++ language isn't sort of standalone. You're almost always dealing with almost like two languages sort of superimposed on each other. Okay, so what's going on is that anything with a pound at the front is a command to something called the C preprocessor, and this is something that preprocesses all C++ programs. So let's see, where did I put my pen? I'm always losing the pen here. Oh, shucks. Okay, well. Oh, there it is. So this story I told you before about the source going through the compiler, in some sense this is true, but it was sort of glossing over some details about what's happening inside that compiler. Okay? And so you can think about any of these compilers really as having a bunch of different phases inside of them. Okay, so I'm going to draw a bigger box here. So here we have our original source code. And the first step is this thing called the C preprocessor. Excuse my spelling. And what that does is it produces another piece of source code. Okay? But what it's done is it's sort of, so for example, that pound include, what pound include literally does is it says, go find the source file, the header file for the IOStream library, and paste it in at the top. Okay, so now the top so many lines of this source file is now literally a copy of the IOStream header. Okay, so the C preprocessor, it's a pretty dumb mechanism. It's really all about sort of cutting and pasting, but automating that process. Okay, so now we've got sort of the IOStream header file up at the top there, and that tells the C++ compiler later on down in your program that, okay, that's you're making a call to some functionality in the IOStream library that matches what the IOStream library is expecting, and it can type check that and make sure that everything's hunky-dory. Okay, and then I'm not going to go into any more detail beyond that, but you still end up getting sort of your executable at the end. Maybe one other detail I should mention is that one of these final steps is called a linking step. And so that's where there's actually sort of a library file with lots of ones and zeros that corresponds to the actual implementation, the code of the IOStream library, and that gets linked in with your executable in that final phase. Okay, so that's what sort of the C preprocessor is all about. Question?
So why does it link to that library if it's already copy and pasted it into your code?
Good question. So I should just make a distinction between what I would call like forward declarations versus actual definitions. So like a minute, just before we saw a thing called area of a circle, right? Float, I'll just call it area for now. Float. So what you can do is do what's called a for declaration, which just has sort of the name of the function and its types for the parameters and the return type, but there's no implementation here. There's no body of the function. Okay, so it's this IOStream header file, or header files in general, typically only include these kind of declarations that say, hey, there's this function that exists, but I'm not going to tell you like how to actually run it. And it's the actual body of the functions, the actual definitions, which are in this separate library. Okay. So for example, let's say you came up with some great idea for this really interesting library, and you wanted to sell it to other people. What you typically do is you'd ship them the header files and these what are called object files, but you wouldn't ship them the actual source code, right? Because then they could sort of copy it and do whatever they wanted with it. But if they just have the executable, then it's just sort of this black box. That's mostly true, not completely true. There's ways to reverse engineer things, but it's difficult. Does that answer your question about? Cool. All right. All right, so back to hello world. Okay, so now let's sort of focus in on the body of the main function here. So first of all, there's this thing called std, :cout. So that's sort of a mouthful of jargon, okay? std doesn't stand for what you think it stands for. Instead, it's just an abbreviation of standard, okay? So this is just saying and what's going on is that inside of the IOStream library, there's something called a namespace. Okay, a namespace is a way of clustering together a bunch of names and sort of adding an extra level of naming around it. And we'll see, I'll actually show you an example right after this of defining your own namespaces. But it's basically a way of helping to avoid name conflicts when you've got really large programs. Okay, so imagine, let's say you had something in your own program named cout. You wouldn't want that to conflict with the one that's in the standard library. And so the standard library has this namespace called std that's wrapped around everything. Okay. So what we've got here is this standard namespace, and then the : is saying access something that's inside of the namespace. In this case, we're accessing something called cout. That's an abbreviation for character output. Okay, so this is this thing that's sort of meant for outputting characters to the terminal. Okay? All right, then what we've got here is a binary operator called the output operator. I think it's called the output operator. Yeah. Think of it a lot like the plus operator. Right? Okay, you've got two numbers, you can plus them together. Here, if you've got an output stream like cout, then you can use this operator, and then on the right-hand side, you can put a string literal, or a string, or a number, or lots of different things, and it'll print it out to the screen. Okay? And then we've got another operator. Okay? Now, like I said, it's a binary operator, so the way you want to read this is as if there were parentheses here and here. Okay? And by putting the parentheses there and not sort of around the hello world and endl, is that what's going on here is that this is a left associative operator. So if you've got a whole sequence of these output operators being used, then you want to think of it being sort of grouping to the left first before you sort of add on the things that are further to the right. Okay? So the first thing that'll happen is it's going to say, okay, output hello world to the standard character output. And then after that, the return value, right, this is an expression here. The return value from this particular expression is just the cout stream itself again. Okay? Which might seem a little bit odd, but it's handy for chaining together these things of output. So the return value is just cout, and then we're going to send this endl, which is for end line, and it basically just puts a carriage return at the end of the line. Okay. That's it. Let's run it. compiling, and then it ran, and boom, there's our hello world. Okay. Any questions at this point?
I have a question. So, and I'm also running Eclipse, and my standard out doesn't seem to show up in my console. Was there something special you had to do, or?
I'm running. Oh wait, let's see. That's a good question. I've seen that behavior too in this last week or so that I've been playing around with this, where it wouldn't show up. You might flip over to the debug window and try running it over there, and it may show up over there. I have a feeling that this might actually be like a minor bug in Eclipse or something like that.
Yeah, and right, and I'm running the latest 64-bit version too, so that.
Yeah.
Okay, thank you.
Great. Okay, so let's talk a little bit more about namespaces. Just so you can kind of see that they're not mysterious, you can create your own namespaces. As you can see, I'm kind of introducing ideas to you as sort of they show up in some of these standard examples. The main function, so we got to talk about functions, or else we can't even talk about a C++ program. Now, we want to talk about hello world, but we need to talk about namespaces, okay? So here's a really simple example of creating your own namespaces. So now we have a new kind of declaration that can appear at the top level. And we've seen functions so far. Now we've got namespaces can show up at the top level. The thing inside of a namespace is also a sequence of declarations. So you can put functions inside of namespaces. You can put namespaces inside of namespaces, and so on and so forth. Okay. Here, I'm giving this namespace the name hitchhikers, and then this other namespace I'm giving it the name guide. Right? You can sort of choose any name you want, as long as it's a valid C++ identifier. There's a few minor restrictions on what C++ identifiers can look like. You can't start with a number, for example. You have to start with an alphabetical character. Upper or lowercase is fine. So those are the namespaces. Now inside of here, I've got yet another new kind of declaration. This is just a variable declaration. Okay? And so here I'm declaring, a variable, the answer. Again, think of it as a bucket. It's meant for holding integers. That's what this int means over here. And then I'm going ahead and initializing it right away to 42. You don't have to initialize variables right away. You could just declare it like that. But I'm going to go ahead and initialize it. Of course, the type, so this is an integer literal, and because it's an integer, it matches up with what we're expecting over here, and we don't get any complaints from the type checker. If I were to instead, let's, just for fun, put in something that's not an integer and see what happens. This might actually succeed. Oh, no, it doesn't. Good. The error message went flying by. Oh, but here we go. Good. This is Eclipse. It's invalid conversion from const char star to int. At this point, you should definitely be thinking, what on earth is a const char star? It's actually sort of a slightly complicated story, but that's essentially the way C++ thinks about these string literals. Okay, so we'll explain exactly what that means in a little while later. But the main point here is that you can't just willy-nilly convert a const char star to an integer. Okay, so this is the type checker complaining about your program. Maybe flipping over to here, type checking happens right about after the C preprocessor. So it happens, one of the first things that the compiler does is type check. All right, so then let's scroll down a little bit. Here we've got another cout. This time I'm printing out sort of two numbers, 42 and 43. but I'm accessing it. Again, here's the namespace name, and then the double colon says I'm reaching inside of that namespace and retrieving out the variable called the answer, which we know is 42. All right, so if I go ahead and run this, let me fix this up here. By the way, before you run your programs, you should have an idea about what you're expecting to see. Okay? It's always a nice moment to stop and think for a second. In this case, it's sort of horrifically easy to understand what it is, but I'm going to think to myself, okay, I'm expecting to see 42 carriage return, 43 carriage return, and that's that. It's nice to set up these expectations because then when you actually get the result, sometimes when we get into more complicated programs, it might be different than what you're expecting because computers do what you say, not what you mean, and that whole business. Okay, but having that expectation set up in your mind is a good one, and it helps you sort of debug your programs. So this just prints 42 and 43. So that's sort of what namespaces are all about. All right, we mentioned variables. Let's dive in a little bit more to variables. Okay? So let's talk about where variables can show up. We've seen them here inside of namespaces. The sort of more common case is for them to show up inside of functions. Okay? And oftentimes these are referred to as local variables. Whereas variables that show up in namespaces or sort of at the top level as a declaration are typically referred to as global variables. Okay? So here now we've got a program. This time we actually have, you can see there's a sequence of statements inside of this program. And the first three statements are all variable. They're a variable declaration plus initialization. Okay? So here's again, I'm computing the area of a circle, but this time without a function. Okay? And I'm just a sequence of computations. Let's go ahead and watch the debugger run on this, and we'll be able to see what's going on with the variables. Okay, so here's something interesting to look at. Right away, the debugger has all these variables here, plus values in them. Why on earth are there already values in the variables, even though we haven't started executing any of these statements? Does anyone know the answer to that? Go for it.
Because the initialization values get calculated at compile time?
No. That's incorrect, but good guess.
I'm going to guess they're just values in the space, in the data, just whatever was there they just grabbed.
Yeah, that's sort of the right answer.
Garbage values. Yeah.
Right, it's sort of garbage values. What's going on is that there's some space in memory inside the computer that's being dedicated to all of these local variables, and that space gets set aside right at the beginning of the function call. Right, so the moment we're executing main, there's already this space set aside for our local variables. And that memory there has sort of random junk in it, okay? From whatever program we ran last, right? We just finished running a namespace function, and so there's all kinds of random bits sitting there in memory. They're still there, and as we're executing this, we see those being interpreted as floating point numbers. Who knows what they were really before that? And what's going on here is that this is sort of a typical thing with C++. You're sort of seeing through sort of the normal C++ abstraction layer, and you're sort of seeing under the hood a little bit of what's going on. We're dealing with raw memory. This is why C++ is fast, but also can be hard to deal with sometimes. So let's just take a couple steps. Good. Now radius has 1. Area now has 3.14159, which is good. And then now, when I execute this statement, what do you guys think is going to go into ret code? What value is going to be in there?
Area?
Right.
3, yeah, which is the value. It's not quite the value of area. It's a little bit different, right? It is 3 and not 3.14. And that's because this sort of rounding happened right there as it was passing from area into ret code. right? And then I'll just go ahead and tell it to resume. And that's that. So the program terminated. Okay? So I think it's probably a good time to stop now. But hope to see you guys back again next Monday for these sort of March Madness